Hello, everybody. We are going to continue with Unit 6, Lesson 9. We're going to get right into the examples here. So number one, looking at the graphs of y equals cosine theta and y equals sine theta, at what values of theta does cosine theta equal sine theta? Where on the unit circle do these points correspond to? So what I'm going to do is I'm going to graph these on Desmos. In fact, I've already gone ahead and graphed them on Desmos. And I graphed them between 0, okay, here's 0, and here's 2 pi right here, okay? And the reason I did that is because between 0 and 2 pi is one cycle, one period of each of the graphs. In addition, it's also one revolution around, or one full rotation around the unit circle. Notice when I graphed these on Desmos, notice I didn't write cosine theta and sine theta. Notice I replaced it with x. You'll have to do that yourself as well. And also, just a reminder, you want your graph to be in radian mode. So they're asking, where is cosine and sine equal? So it looks like it happens here and it happens here. Okay, so it happens at pi over 4 and 5 pi over 4. Okay, that's where sine and cosine are equal. So to answer the first part of that question, at what values of theta do cosine theta equal sine theta? So it's going to be at theta equals pi over 4 and theta equals 5 pi over 4. If we go back to our lesson notes from lesson 1, to give you an idea, pi over 4, we can see here is 45 degrees, okay? And 5 pi over 4 is 225 degrees, okay? So that gives you an idea in degrees of what those angle measurements are. So this is 45 degrees, and this is 225 degrees, okay? Where on the unit circle do these points correspond to? Okay, well, these correspond to points on the unit circle. All right, if we were going to draw a picture, let's draw a picture of a unit circle. All right, so pi over 4, or 45 degrees, is halfway between 0 and 90. So that would be about right here. Okay. Remember, this is 0. This is pi over 2, or 90 degrees. This is pi, or 180 degrees. And this is 3 pi over 2, or 270 degrees. Okay. 5 pi over 4, that's going to be halfway between 180 and 270. So 5 pi over 4 is going to be here. So where on the unit circle do these points correspond to? I just drew those for you. Okay, so pi over 4 is in quadrant 1. Okay, and 5 pi over 4 is in quadrant 3. Remember, the quadrants are 1, 2, 3, and 4. Okay, so those are the points where cosine and sine have the same value. So that's number 1. Number 2, for each of these equations, first predict what the graph looks like, and then check your prediction using technology. So the first one is cosine plus sine. So let's go to Desmos. So if I look at cosine plus sine, so for example, if I start at 0, okay, that looks like cosine has a value of 1 and sine has a value of 0. So cosine plus sine is going to be at 0, okay? When I get to pi over 4, they have the same value of approximately 0.7. So cosine plus sine is 1.4. So that's going to come somewhere up here. So it's going to be about up here somewhere. Okay, so it should start at 1 and then kind of go up here. When I get to pi over 2, I have 0 and 1. So it's going to go here, then it's going to go up, then it's going to come back down. Okay. When I get to 3 pi over 4, I have 0.69, and it's about negative 0.69. So that will come out to 0, so it'll come back down to 0. So I would think it's probably going to have this wavy shape, but the height of the wave is going to be bigger. Okay, let's see what happens. Okay, let me take those out to make it easier to see, and you see that's what it does. It does kind of have that wavy shape, and then comes up, then it comes all the way down over here, and it comes back up again here at 2 pi. Okay, so that's A, cosine plus sine. The next one is cosine squared theta. So that means cosine, whatever the value of cosine is, but square it. So let's take a look at cosine here. Okay. So if I start at 0, that's going to be 1 squared. Okay, because the value is 1, so it'll start at 1. At pi over 4, it's about 0.7. So 0.7 squared, if we go on Desmos here, 0.7 squared is 0.49. So it's going to start here, but 0.49 is going to actually come down to about here. And then pi over 2, it'll be 0. So it'll come down kind of this way here. Let's see what happens when we graph it. So cosine squared of x, and you can see that's what it does. Okay, it still has that shape, but notice it never goes negative, because when I square a negative, it becomes a positive. Okay, so that's what cosine squared is going to look like. The next one, I believe, is sine squared. Yeah, cosine squared and sine squared. So if we look at sine, let's look at the graph of sine. Okay, sine again starts and ends at 0. Okay, so at 0, 0 squared is 0. So it's going to start at 0, just like cosine squared started at 1. All right, at pi over 4, it's at that point close to 0.7. And we saw that 0.7 squared is 0.49. So it's going to go up, but it's only going to go up to like here. It's going to go up here. And then at pi over 2, it's going to go to 1. So 1 squared is 1. So it should come up, but it's not going to be as steep. Okay. And then it's going to work its way down. So we're back at 0.49 or 0.7 over here. So 0.7 squared is 0.49. So it should come back down to 0, But then instead of going negative, it should come up again, because when I square a negative, it becomes a positive. So let's see that it indeed does that. So sine squared of x or theta, and you can see it does do that. So it comes up to 0.49, which is 0.7 squared, goes up to 1. 1 squared is 1. All right, comes down to 0.49 again, down to 0. But then instead of getting negative, it goes in the positive direction. So where the sine graph is normally negative, it becomes positive. Okay? So that's the sine squared graph. Okay? The last one is cosine squared plus sine squared. So let's put those two graphs up. Okay? So cosine squared plus sine squared. So if I start at 0, that's going to be 0 plus 1. So if I add these two graphs, it's going to start at 1. At pi over 4, it's at 0.5. So 0.5 plus 0.5 is 1. So it's going to stay here. Okay. What about here? I have 1 and 0. Again, it's going to stay at 1. It almost looks like this is going to stay at 1, because when it comes down to here, again, this will be 0.5 plus 0.5, which is 1. 1 plus 0, which is 1. So it would appear that cosine squared plus sine squared is always going to be equal to 1. And if we do that, let's see what happens. Let's see that it indeed does that. And you can see it always stays at 1. Okay? So it turns out if you take the cosine and you square it, you take the sine and you square it, and then you add those two values together, you always get the value of 1. In fact, if we go to our lesson notes, okay, that is known as what we call the Pythagorean identity. Cosine squared and sine squared, okay, is always, if we add those together, we're always going to get 1, because cosine, remember, goes with x, sine goes with y, and that's our equation of the unit circle. But to go back to this lesson, again, the purpose of this was to in number 1, we just looked at the graphs of cosine and sine. So remember, cosine and sine have very similar shapes. Okay? They both have the wavy shapes. The difference being cosine starts at 1, goes down, and then comes back up to 1. Whereas sine starts at 0, goes up to 1, goes down to -1, and then up to 0. So we started by looking at those graphs and seeing where those values are the same. All right. And then we used those graphs to predict what each of these graphs were going to look like. Okay. So if you could follow along with my logic here, then you pretty much got the purpose of what this lesson is and what we wanted to learn from this lesson. Okay. So that is it for lesson 9.